So right now, we're tasked to solve for the H if the maximum flexure is limited to 20 MPa. Okay, so whenever natin gingon nga maximum flexure, we have to always bear in mind, class, nga dili lang sa positive nga moment ra ta mo tan-aw nga 5, but also kung naay negative moment ato sad siyang i-consider. Kaya again, lain og effect ang positive moment from the negative moment. And by the way, wala na ko na show ganina ang negative moment. Kung negative moment gani, so for example, mo ni ang exaggeration sa ato ang deflection. Negative moment kay concave downward man. So this is the neutral axis. So may tabo, this time the upper fibers kay will experience compression, no? Tanan nga fibers above the neutral axis will experience tension, no? Tension akong giingon ganina. So dapat tension, no? Kay makita masad nato. Diri nato makita ang cracking, no? Cracking ni crack siya kay na lose na ang iyang bonding sa iyang material. And then diri nga portion sa atong fiber kay na diri nag-compress. So therefore compression ang mahitabo diri dapita. This is negative moment, no? So mag-compress siya, magkahuot ang fiber diha. So diri kay tension nya, dara kay compression. That's the difference between the positive moment and the negative moment. So negative moment na siya. Okay? Right, going back to solving, mo to siya, no? We have to always consider the positive and the negative moment. And then we have this value flexure. So ato sa i-write ang formula sa flexure. That flexure is MC over I na lang akong ibutang because we're talking about maximum flexure. And then if that's the case, this is going to be now maximum kaning flexure nga symbol, right? And we're gonna solve for the every term or every element. Let's just consider solving the C first. So the section ato lang sa ni siyang ikat. This is the section, and ato siyang i-paste here. So this is the section, and then if we're going to draw a horizontal line na nasa middle, then this represents the C value, C1, and the C value here, C2. So therefore, for rectangle, C1 is just equal to C2. And it's obvious that C1, pila day value sa itong C1? C1 is equal to 1/2 of H. Okay, wala man tayo value sa H, no? And also C2. So this is also C2. So by the way, this is all C, no? Okay, C1 and C2 are just the same. So C raday na siya. Then let's solve for I. I for a rectangle, it's BH cubed over 12. So our base na to kay 80. So isuwat na ko, this is 80 H cubed, no? Over 12. That is our I. And then let us now consider first positive moment. So if positive moment atong i-consider una, it's positive 5. No, so what's nato? Moment here is 5. Okay. And then flexure, maximum flexure is pila gingon sa problem? 20 MPa. So this is 20 MPa or newtons per square millimeter. By the way, do not forget that this 80 here has a unit mm. No? So do not forget that. Okay, let us substitute the values from mc over I. So this is 20 newtons per square millimeter equal to m nga. This m here is kilonewtons meter ha. So that's 5 kilonewtons meter. So para ma-convert na siya, mahimo na siyang 1,000 square. Para mahimo siyang newtons millimeter. Yeah, ma-cancel out na tayo na siyang kilonewtons and meter diha. And then continue. C here is h over 2 or 1/2 over 1/2 of h, or that's h over 2. And then for our I, it's 80 h cubed. So it's 80 yeah, h cubed over 12. So kung makita na to, the gantag ma-cancel out. This one, ma-cancel out na to si mm and another mm. Si h pod o gani mahimo na ni siyang h square. And then this 2 and 12 mahimo na ni siyang 6. Then also si newtons diri sa pika side. So ato lang i-rewrite para makita ta sa transition. It's going to be now 20 over mm square equal to this is 5 times 1,000 and square it. Ato lang sa ni siyang i-reason, kita asra kaayo. And then divided by 80 h square over 6. So masolve na nato sa h square. So h square is just equal to, no, kani siya mapunta na siya dito sa other side. Nahimo na siyang 5 times 1,000 square na mm square, then 80 times 20 over 6. Then h now is, that's 5 times 1,000 square times divided by 80 times 20 divided by 6, and you get the square root. The answer is 136.93. So 136.93 millimeters. No, this is our h. Is this the final h? No, dili pa, because napatay usa ka value nga negative. So influence. Consider the negative moment before ta mo conclude. So our negative moment is negative 1.25. Then akong giingon ganina, you just get the absolute value and substitute from this one, mc over I. So the same gapon, our flexure is 20 equal to here 1.25 times 1,000 square times h over 2 divided by 80 h cubed over 12. So masolve na nato si h with this. Ito sang i-reset. That is 1.25 times 1000 square and divided by 80. At isang tanawon, balik ko na to. So therefore, our answer for H, this is 68.465 millimeters. Ato sa i-double check kung sakto ba na siya. So that's 1.25 times 1000 square times 6 divided by 80 times 20 and square it, 64.465. How about this one? Atong i-double check lang. It's 20 times 5 times 1000 square times 0.5 or times 6, and then this is 80 square, and the value this is 30. So the value is at isang waton 136.93. So we have two values, and since dimension man ang atong gisgutan, no, whenever dimension, so i-take note na to dere, when designing always when designing a dimension, so dimension, so ito bang spelling sa dimension? Wait sa dimension. Okay, no, when designing a dimension, always choose the bigger value. Unlike sa katong P gani, whenever nag-decide ta kung unsay maximum load ang atong ginapili kay ang pinakagamay nga load, no, that's investigation. Yeah, kani kay designing na siya for a dimension, so always choose the bigger value. So ato ning i-highlight. So i-highlight na nato siya. Okay, para di mo makalimot. So therefore, HDI is equal to 136. Oops, ano man siya? 136.93 millimeters. It's really hard man to give instruction to our mga skilled worker. So dapat untop-untop gyud by tens. So to the next divisible by 10. No? So or something like that. Pwede ra gud na ang 136.93. But kung mag-give tag instruction sa atong mga skilled workers, it should be in divisible by 10. No? Ma-appreciate na nila. Okay. This ends our example number 2.